Hi and welcome to this online training session for Automation Studio. In this video, we will create an RLC circuit and see how to analyze it with an oscilloscope, a multimeter, and an electrotechnical plotter. Let's start by creating a new electrotechnical diagram and selecting the NEMA standard. An RLC circuit is a commonly used circuit which has a resistor, an inductor, and a capacitor connected in series. First, select the electrotechnical module and then expand it. And we'll first need a power supply. So in the power, we'll choose energy source and the AC source. Now we'll need some passive components. So in the passive and active components, we'll drag in a resistor, an inductor, and a capacitor. The components being small, we can adjust the zoom level in the View tab and zoom all components. To rotate components, select the Edit ribbon, and under the Position button, you can select your component and then rotate them 90 degrees. With a few clicks, you can create your wires and easily edit the layout afterwards. The property of the RLC circuit is that the voltage phase shifts from a component to the other. Therefore, we will use an oscilloscope to analyze this behavior. We can start simulation in the Simulation tab and adjust the position holding down the space key to pan. Opening the oscilloscope, you will see that each channel has by default a single ground probe. By clicking this ground button, you can switch this option for having individual ground probes for each channel. Then you can turn on the different channels that will be required, and clicking on the probes will have them to pop out and you'll be able to use them in your circuit. So you can connect them to the resistance, to the inductance, and to the capacitor. One can do individual adjustments for each channel or use the auto scale button. We can now notice that the tension or the voltage of a purely inductive component, as the red channel here, is leading the tension from the resistance by 90 degrees, which means that at the point where the tension in the resistance is zero, the tension in the inductance is at its full value. In the same manner, but in the opposite way, the tension at the capacitor is at its lowest value, while the tension at the resistance is zero, so it's said to be dragging from 90 degrees. There are some other measuring instruments available in Automation Studio that can be used to analyze electrical circuits. In the Simulation tab, there is a multimeter. That multimeter can be used to measure the tension at the source, for example. If one wishes to have drawings or to plot the values of different variables, one would have to use the measuring instruments from the library. To do so, go back in the library and open measuring instruments. You can then drag a voltmeter from there and an ammeter. Now one has to open the electrotechnical plotter and simply drag and drop those measuring instruments onto the plotter and then select the voltage and the current. And now as you go back to simulation, you can get rid of the multimeter. You can expand the extra properties of the plotter and hit auto rescale. And as you can see here, both signals are perfectly in phase. Thanks for watching this online training video for Automation Studio. We invite you to watch the other videos, and we'd like to thank you for your time.